Hello AP Chemistry and welcome to section 16.5, strong acids and strong bases. So, for starters, memorize them, okay? You have to memorize them. There's no way around that, okay? And if something is strong, right, by definition, right, if it's a strong acid or strong base, it's a strong electrolyte, which means, ding, 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 dissociates completely. Therefore, we are talking not about equilibrium systems, right? So, for example, if I was talking about a strong acid in water, right, I would use just a forward arrow and I would to indicate that I make hydronium and I make chloride ion, right? Going back to HA plus water gives us hydronium plus A minus, right? Forward arrow only because whatever we start with here, so for example, if we have 0.1 molar this, we end up with 0.1 molar this, 0.1 molar this, and how much of this is left at the end? Right, 0. Yes? And that's the assumption that we make. Which means that if we were going to write a Ka expression, right, Ka being dissociation of, or equilibrium constant for my acid, right, or acid dissociation constant, right, we would talk about my H3O plus, and we would talk about my chloride ion over my HCl concentration, and what kind of Ka value would this be in terms of magnitude? Ginormous, right? Approaching infinity, because this should be approaching 0, yes? If not actually 0. Yes? Makes sense? Great. Which is why this is not an equilibrium system, right? Because it's a strong electrolyte, right? Likewise for a strong acid or a strong base, right? Which again, you need to know what those strong bases are. Now, here is one of those times where adding the water is sort of weird actually in terms of a strong base, right? When I take something like a strong base and water, the equation kind of doesn't make sense, right? Because the whole point is I'm going to make some of this, and I'm going to have my deprotonated form, right? And there's really no need for the water, which is one of those strange things when we're talking about strong bases. So for strong bases, that's generally the one time it's okay to exclude the water. Otherwise, it just kind of sits there, and that's fine too, right? Then you could even put it back on this other side if you wanted to, right? So anyway, strong bases, same principle, right? If I was going to talk about a Kb expression, a base dissociation constant, right, I could talk about my hydroxide and my conjugate acid over my original, but again, strong species, this should be approaching 0, this should be approaching infinity. Now, in terms of my species, right, this is my acid, and this is its conjugate base. This is my base, and that's its conjugate acid. Yes? All right. Moving along. Practice. An aqueous solution of nitric acid. What should we be thinking about? Ding, ding, ding. Strong acid has a pH of this. What is the concentration of the acid? So again, strong acid means dissociates completely. So if I know that I have a pH of this, or in other words, 10 to the negative 2.34 is going to give me my hydronium ion concentration. I know that all this hydronium came from here at a 1-to-1 ratio. Yes? Makes sense? All right. Likewise here, what is the concentration of a solution where KOH is equal to this, right? Or of KOH where pH is equal to this. So that means 10 to the negative 11.89 gives me what? Right, gives us our H3O plus. And again, just like the previous ones, right, multiple ways to solve this, right? If I want to, I can subtract this from 14 first, right, and take what's left over, right, which would be like, what is that, 2.11, right? So this would actually give me my hydroxide ion concentration, right? And I know that for KOH, hydroxide ion concentration is a 1-to-1 ratio. Here, what makes this one a tiny bit different than this one? Right. 2-to-1, actually, right? Which means that when I take calcium hydroxide, for example, and I make calcium ions and 2 hydroxide ions, meaning that when I get my hydroxide ion concentration, I have to factor in that there for every 2 moles of this, 1 mole of that. Yeah? All right. Next up. Oh, I forgot to put my handy little dot at the bottom. Anyway, this is it for strong acids and strong bases. Probably the shortest section of the chapter. All right. Thank you for listening. Be good. Please memorize your strong acids and strong bases, and I will see you soon. Bye.